What's up, you friggin' genius? So, in this video, I'm going to teach you how to evaluate algebraic expressions, okay? And evaluate is just a fancy way of saying solve. So, I'm going to teach you how to solve algebraic expressions. Okay, so let's start with this example right here. Let's say you were asked to evaluate x plus 7. And let's also say that it was given to us that x is equal to 3. Okay, so how would you evaluate this, x plus 7? Well, we're being told what x is, right? So we're being told that x is equal to 3. So that means I'm going to plug in a 3 right here for x. So instead of x plus 7, I'm going to have 3 plus 7. Okay, and then we can simplify this more, right? What's 3 plus 7? 10. Okay, can't simplify that anymore. So this is your answer, simply 10. And one thing I want to point out here is when we're evaluating expressions, we don't use equal signs, right? So I didn't use an equal sign here at all. Now, there's an equal sign over here, right? But that's because this was given to us. But when we're solving the problem, going through our steps, right? We went from here to here to here. When we're solving, we don't use equal signs. Okay, because expressions don't have equal signs. Equations do, right? Equations have equal signs, but expressions don't. All right, so with that in mind, let's go to the next example. Okay, let's say we were asked to evaluate y minus 5. And let's say y is equal to 9. Okay, so we have y minus 5. We're being told y is 9. So that means we're going to plug in 9 for y right here. Okay, so instead of y minus 5, I'm going to have 9 minus 5. Okay, and then we can simplify this, right? So what's 9 minus 5? That's just 4. Okay, so 4 would be your answer. Let's try another one. Okay, let's stick with y minus 5 one more time. But this time we're going to say y is equal to 3. Okay, so in this case, that means we're going to plug in 3 for y right here. So instead of y minus 5, we're going to have 3 minus 5. Okay, and what's 3 minus 5? Negative 2, right? Because we have a small number and we're subtracting a bigger number. So that's why our answer is negative. So negative 2. Okay, let's try another example. All right, now let's say we were asked to evaluate 5a. And let's say a is equal to, let's say 3. Okay, now whenever you see a number and a variable like this next to each other and there's no sign in between them, this always means multiply. Okay, so 5a is the same thing as 5 times a. Okay, and I'll just rewrite it just to make sure you can see it. 5a is the same thing as 5 times a. Okay, so now we're being told that a is equal to 3, right? So we're going to plug in a 3 for a right here. So instead of having 5 times a, I'm going to have 5 times 3. Okay, and we can simplify this, right? What's 5 times 3? That's just 15. So 15 is your answer. Okay, let's try another one. And let's try this problem one more time. So let's say we were asked to evaluate 5a, but this time let's say a is equal to negative 2. Okay, so remember, we have a number next to a variable. There's no sign in between them, so this is the same thing as 5 times a. Okay, and now we're being told that a is negative 2, so that means we're going to plug in a negative 2 right here for a. So 5 times a is going to turn into 5 times negative 2. Okay, now 5 times negative 2, what is that? Well, 5 is a positive number here, right? And then 2 is a negative number here. So whenever you multiply a positive and a negative number, your answer is going to be negative. Okay, so we figured out our sign, so now we can just solve like normal. So now let's just do 5 times 2. What's 5 times 2? 10. So positive 5 times negative 2 is negative 10. Okay, let's do a few more. Okay, now let's say we were asked to evaluate x over 2. And let's say that x is equal to 8. Okay, now this fraction here is the same thing as division, okay? So x over 2 is the same thing as saying x divided by 2. Okay, so in either case, we're being told that x is equal to 8, so that means we're going to plug in an 8 right here for x. So instead of x over 2, I'm going to have 8 over 2, which again would be the same thing as 8 divided by 2. So what's 8 divided by 2? That's just 4. Okay, let's try another one. Okay, so let's try x over 2 one more time. But now let's say x is equal to negative 10. Okay, so that means I'm going to plug in negative 10 for x right here. So instead of x over 2, I'm going to have negative 10 over 2. Now we have a negative number, right, divided by a positive number. So whenever we have one of each, this is going to be negative. So whether you're multiplying or dividing, these signs have the same rules. Okay, so our answer is going to be negative, and then so we have 10 divided by 2. What's that? 5. Okay, so your answer is negative 5. Okay, let's try another one. Okay, now let's say we were asked to evaluate 16 divided by 4x. And we're going to put 4x in parentheses. Okay, and we're also going to say that x is equal to 2. Now, before substituting this x equals 2 into my expression, I'm going to simplify this a little bit. So 16 divided by 4x, this is the same thing as 16 divided by, and remember we have a number next to a variable with no sign in between them, so that means multiply. Okay, so 4 times x. Okay, so now I'll plug in this 2 for this x right here. So I'm going to simplify this again, and it's going to be 16 divided by 4 times 2. Okay, now what's my next step? Well, if you remember your order of operations, you always do parentheses first, right? So since we have parentheses right here, that's where we're going to start. Okay, so what's 4 times 2? Well, that's equal to 8, right? Okay, so we did what was inside of our parentheses, so now I'll bring down the rest of my problem. So this 16 divided by part. So now all we're left with is 16 divided by 8. And what is that? That's simply 2. Okay, now let's just do a couple more. Okay, now what if we were asked to evaluate 5 to the x plus 1? And we're being told that x is equal to 2. Okay, and just as a reminder, this little x up here, that represents an exponent, okay? So we're having 5 raised to an exponent, or to a power, and then we're just going to add 1 at the end. Okay, so let's do that. We're being told that x is equal to 2, right? So I'm going to plug in a 2 for this x right here. So instead of having 5 to the x, I'm going to have 5 to the 2, or 5 squared, or 5 to the second power, however you want to say it. And then again, we're just going to add 1. Okay, and again, if you remember your order of operations, simplifying exponents here, like 5 squared, comes before any addition or subtraction. Okay, so we're going to simplify this part first. So 5 to the second power, what is that? Well, that's the same thing as 5 times 5, right? And 5 times 5 is 25. Okay, so we simplified this part with our exponent. Now we'll bring down this plus 1. Okay, so now we're just simply left with 25 plus 1, which simplifies to 26. Okay, there's your answer. Okay, so for this last problem, let's say we had 3p squared plus 4p plus 1. And let's say it was given to us that p is equal to 3. Okay, so we know that p is 3, so that means I'm going to plug in a 3 wherever I see a p here. Okay, but before doing that, I'm going to simplify my expression a little bit. How can I simplify this? Well, remember, whenever you have a number next to a variable and there's no sign in between them, that means multiply. Okay, so we have 3 times p squared. And then we're going to add 4 times p. And then we're going to add 1 at the end. Okay, so now I simplified my expression a little bit. It's a little easier to work with. So now I'm going to plug this 3 in to here and to here, right? Because that's where the p's are. So I'm going to have 3 times 3 squared plus 4 times 3 plus 1. Okay, so now how do we start simplifying this? Well, remember, according to our order of operations, we always start with parentheses. Do we have any parentheses here? No. Okay, next comes exponents. Do we have any exponents here? Yes, we have an exponent right here, right? So this is where we're going to start, 3 squared. So 3 to the second power simplifies to 9, okay? So we just dealt with our exponent. There's no more exponents left, so let's bring down the rest of our problem. So now we have this 3 times right here. Then this plus 4 times 3 plus 1. Okay, so there were no more exponents. So next in the order of operations comes multiplication and division. So do we have any multiplication and division here? Yes, we do, right? We have multiplication here, and we also have multiplication right here. But which one do I do first? The 3 times 9 or the 4 times 3? Well, when you have the same sign, so we have multiplication here and here, you always do the one that's furthest to the left first. Okay, so 3 times 9, that's where we're going to start. So 3 times 9 is 27. And then we'll do this one, 4 times 3, which is 12. Okay, there's no more multiplication left, so I'm going to bring down the rest of my problem. So I have this plus sign right here, and then I have this plus 1 right here. Okay, so now we're simply left with 27 plus 12 plus 1. So 27 plus 12, that simplifies to 39. And then we have this plus 1 right here, right? So we'll do plus 1. So we're simply left with 39 plus 1, which is 40. And there's your answer. All right, guys, so that's how you evaluate algebraic expressions. I hope the video was helpful. If it was, definitely leave a thumbs up down below. It's always appreciated. And if you got any questions, leave them in the comment section below, and I'll do my best to try and help you out. Also, there's a pre-algebra playlist attached at the end of the video. So if there's any other topics you need to check out, definitely check those out, and I'll see you there.